good afternoon, and for today we'll be discussing chapter 5, which about roots of equations. Okay, so today we will be discussing two methods, the bracketing methods and false position method. Okay, so these methods belongs to the bracketing methods. So say for example, you have x squared plus 5x plus 6 or is equal to a function. Okay, so how do we get the roots of this equation? Okay, so the roots of this equation is the value of x that will make the value of y equal to 0. Okay, so you have this one, x squared plus 5x plus 6 is equal to 0. Okay, so this is your equation. So luckily for this example, this is a quadratic equation, and we have this formula, the quadratic formula, negative b plus minus square root of b squared minus 4ac over 2a. Okay, so this is used only for quadratic equation. Now the way to solve this one is that you simply input the given values. However, for higher order functions or polynomials, it is not that easy to determine the roots of the equation. By the way, the roots of equation has many applications. Example, for solving differential equations, you need first to get the roots of the equation. Okay, so the knowledge of getting the roots of equation is very important. Okay, so one method that you can use, say for example, you're given this equation if you are given this equation, f of c is equal to gm over c times 1 minus e negative c over m times t minus e. Okay. Okay. So how do you get the roots of this equation? Well, pwede nimo sa mga bana-bana, no? Saan man, you use graphical method. Okay, graphical method. Say for example, when m is equal to, say for example, m is 68.1 kilograms and t is equal to 10 seconds. 10 seconds. We know that g is 9.8 meter per second square, and v, the velocity, is 40 meters per second. Okay, so if we plug in the values, you have this equation. F of z is, ako na lang i-multiply largo, no, ang g and m, which will result to 667.5 38 over C 1 minus E negative, okay, klaro, negative 0.146,843 C minus 40. That is your equation. Okay. So if we use the graphical method, bato ni mana is you plug in values for C. Okay, sample 4, 8, 12, 16, 20. So ang interval by 4. Anyway, you can plug in any values that you want. Okay, this will result to okay. So kung i-graph natin ito, we have 4, 8, 12, 16, 20. Okay, so you have 4, 34. You have 10. Okay. 434. Okay. 817. Over here. And then 12.6. Over here. 16 negative 2. 16 negative 2. Somewhere. Burahin ko na lang, no? Somewhere here. And then 20 8. Okay. So this is your graph. Okay. Now, where is the root? The root is this point. Okay. The point where it touches the x-axis, or the y is equal to 0. The value of x that will make the value of y 0. Okay, so using graphical method, you can estimate that this is somewhere around 14 or 13. No? So the problem with graphical method is it is not exact, or it is only an estimate. Okay? So what you have observed is after sa roots nimo, no? Before sa root, the value of y is positive. After sa root, the value of y is negative. Okay, so there is a change in the sign of the value of y. Okay, so observe na ni mo diri. Okay, the value of y is positive and negative. So therefore, somewhere around here is the root. Okay, now you need to take note of this fact because we will use that one later on using the bisection method. Okay, so that's it for the graphical method. Now in this class we will not use the graphical method, but we'll use other methods. But again, kaning concept magamit nato later on. Okay, so let's proceed with the bisection method. Okay, so let's proceed with the bisection method. And for this example, we'll use this equation, the equation that we used last time. Okay, this one. And the idea of the bisection method is using your graphical method. You have learned that the root, this one, okay, no? When it touches the x-axis, the sign of the y value or the becomes changes, no? Changes from positive to negative. Okay, so using that one, we can deduce that the root is somewhere around this interval. Okay, around this interval AB. No, so naa dira somewhere around here ang imo root. Okay, so knowing that one, ang buhato nimo is mura nimo siya og kaninga length wala na siya og papel, imo nang i-fold o katungak. Okay, so what happens when you fold this in half? This one. So kung i-fold na nimo katungak, mabilin is duha ka partition, this one and this one, right? Okay, so based on this, by the way, ito ning isibog kay mura o sibog lang nato ni, okay? Sibog nato somewhere around here. Okay, this is the root para mas klaro itong presentation. Okay, so asa dapit na belong ang imong root in this first or the second? So using the graphical, second, no, sa first interval. Okay, sa first interval. But in the bisection method, we will not use graphical method. So in order for you to know nga naa ni siya na belong sa first method, imo na siyang i-check, no? Imo na siyang i-check. Okay, so ang value ng A, ito na lang, it is na ng A, this will be your lower bound and this will be your upper bound. Okay? Lower bound and upper bound. So na ay tulo ka values. Ang value sa tunga kani, this will be your XR. Okay, XR or the ang XR will be XL plus XU over 2. Muna ito ang bisection because naka-interval, imo siyang i-divide into 2. Bisect na mo into 2. Okay? So para may balaan nimo kung ang imo ang roots is naa sa first or naa ba sa second, imong i-multiply ang value sa f of XL times f of XR. Okay? Kana sa. So, kung less than 0 ang answer ani, kung less than 0, pasabot, na i-change sa sign, no? Negative times positive is negative, manong less than 0. So therefore, may ba nimo, naa diri sa first, nasa first. Naa diri sa first. Kay kung greater than po siya, f of x L times f of XR is greater than 0, so ipasabot ana. Sabot ana, naa diri sa second. Ano naman, kay negative times negative is positive, right? Positive times positive is positive, greater than 0, no? So meaning there is no change in sign. Anyway, ito na sa layout ng ang yung procedure later on. Now, if f of xl times f of xr is equal to 0, meaning ana, the roots is na determine nimo. Kaning xr nimo will now represent the root. Okay, kaya ang concept ani niya is you have xl, you have xu, you assume that xr is situated between xl and xu. Okay, but based on the diagram, ang xr nimo wala pa man mitunong sa x sa imong roots. Kasi ang buhaton nimo ana is you proceed. Kuhaon nimo ning so na-dere mo ang root, right? So this will be your xl. And then kaning xr nimo, ang xr nimo xr1 man xr1. Kaning xr1 nimo iset na nimo sa bag-o nga into the new interval. Set na po na nimo sa xu and then assume that xr2 is assume nimo nga ang location sa imong roots is nasa tunga-tunga dire until mo gamay na siya kaayo mo gamay na siya kaayo nga matong na gid nimo ang matunong na gid nimo kadugayan ang roots. So that is the concept of bisection method. Okay, for the procedure nasa inyong book. Okay? So for the procedure, first step is choose XL and XU. So unsa ano yung pag-choose sa XL and XU? Ang XL and XU mo na ang numbers nga nag-contain sa imo ang roots. So in the case kaganina, XL is equal to 12 for this equation and XU is equal to 16. So may bawaan na nimo sa mas mayo i-graph nimo ang equation para makuha nimo mo din akong interval. Okay? That is the first step. Now, kung gusto nimo ma-ensure nga na-contain niya ang maugid sa ang sakto nga interval, i-check na nimo by f of xl times f of xu. Dapat ang answer ani will be less than 0. Okay? Less than 0. So, kuwanda na siya. Checking. Check nimo kung masatisfy niya meaning sakto gid ang interval. Kay kung greater than ang answer ana, meaning mali na nga interval, wala na contain ang roots. Number 2, step 2, set the value of the root to this one, xl plus xu over 2. Okay? So muna siya, assume nimo. Okay? Nga ang imong location sa imong rows is at the middle of this interval. At third one, katong gi-discuss na ako kaganina, the third one is evaluate kung asa na belong ang imo ang roots, asa nga half or interval, sub-interval. Okay? So, i-check. So, ano yung pag-check? Multiply f of xl times f of xr. So, if the value is less than 0, the root lies in the lower subinterval. So, kung sa lower subinterval, set xu equal to xr. So that is case A. Case B is if f of xl times f of xr is greater than 0, the root lies in the upper subinterval. And oh, by the way, napanisumpay di ay and then return to step 2. Set xu equal to xl equal to xr. And return to step 2 and return to step 2. For the third case, if f of xl times f of xr equal to 0, pasawat na the root equals xr. Okay? Terminate the computation. Okay. Sumura na siya. Sumubor kaya ang procedure. Now, take note nga kaning procedure mao ni pod ang imo ang flow sa imong pag-program. Okay? Sa imong pagbuhat og pseudocode. Okay. Kung ano yung reason, we will solve this equation. Okay, so nanatay xr, xl is 12, xr is 16. Okay? So you can check ang f of xl, f of 12. F of 12 is filament. .067. F of 16 okay, the f of 16 is negative 2.269. Okay, now if we multiply f of 12 times f of 16, the answer is negative times positive, negative, less than 0. Okay, so therefore it satisfies the condition for the interval. Okay, so with that, proceed to the next step, step 2. So xr, tangan na to xr1, okay, will now be, saan man, what is the value of xr1? xr1 will be 12 plus 16 over 2, or 14. Okay, so this is now your first location for your roots, right? 12 man to, then 16, then somewhere here ang imong roots. Okay? So, ang buhatan na to is we get the value of f of 14. F of 14 is 1.569. Okay? 1.569. And then we check whether ahana belong ang interval. Our sub-interval. So you have f of xl or 12 times f of 14. Okay? So f of 12 is 6.067 times 1.569. So the answer is greater than 0. So kung greater than 0, sa itong button, the root belongs to mali din eh. Ang root is nakalidiri. The root belongs to the upper subinterval. Okay? Upper subinterval. So kung sa upper subinterval, kasabot ani upper subinterval. So kung nag-belong sa upper subinterval, button nimo is set xl equal to xr1. Okay, therefore ang new interval is 14 and xu is 16. Okay? So kani naa diri mong roots. And then proceed to step 2. XR2 is, by the way, sa book XR ang butang, pero in our solution ato lang butan og XR1, XR2 para makita nato ang flow. Will be 14 plus 16 over 2. So may maning 15. Okay? 15. Okay. By the way, so kano sa man mo stop ang ato ang computation. So mo stop ang atong computation if the relative error is within the tolerable value. So mag-set ka og error, no, relative error. Okay? Anyway, solveon sa nato ni, and then we will proceed with the error later on. So f of 15 is pila ang f of 15? Negative 0.425. Okay? So ano siya? Therefore, f of 14 times f of 15 sa answeran eh. Ang f of 14 is 1.569 times negative 0.425. Okay? So the answer is negative, less than 0. Therefore, sa button ni mo, set sa button ni lower, nasa lower sub interval. So set xu is equal set xr2 equal to xu. Okay? So natay new interval, you have xl, xl 14 and then xu 15. Okay? So, you have, by the way, you have XR 3, 14 plus 15 over 2, 29 over 2 is 14.5. Okay? 13.5. Okay. Okay. So, magpadayon na siya nga method until mo converge ang imong solution. So, when does your solution converge? So, for example, natay by the way, irason na ako eh. No, na-erase na noon. Natay stopping criterion. No? Our stopping criterion is the approximate error is less than 0.5%. Okay, so unsa na siya pagkuha? Ang imo ang approximate percent relative error is XR new minus XR old over XR new times 100%. Okay? So, katong kaganina, ang atong XR1 is pila galit to? Itong XR1 is 14, XR2 is 15, XR3 is 14.5. Okay? So, ang ato ang corresponding error ani zaman 15. By the way, diri na deka sa after nimo pagkuha sa bag-ong roots. So you have EA is 15 minus 14 over XR new 15. So 1 over 15. So 1 divided 15 times 100 is 6.67%. Okay? Yang atong stopping criterion dapat less than 0.5. So layo pa kayo. So you have 14.5 minus 15 over 14.5. Yan na. 0.5 divided 14.5. Okay, 3.43%. Okay, for this equation, the true value of the root is 14.7802. Okay? So mao daw ni ang true value for this equation. Meaning mo gid ang exact value niya ba? Or ang exact root niya. Okay? Now, kani siyang error. This is the approximate percent relative error. Okay? Approximate relative error. Now, kung given ka sa true value, ang true value sa error will be, you have true value minus approximation over true value. Okay? Muna siya. So, ang true, ang name po dali niya is true percent relative error. Okay? So, ay mo kalimot kalibog aning E sub T and E sub A. E sub A meaning approximate. Approximate siya because ang imong value dire is based sa previous value. Dili sa true value. Now, usually, dili man po ka-given og true value. Kaya kung given ka og true value, given ka ani, wala na sense. Anong solvon pa rin mo nga given naman ka sa value, no? So, mo na siya. Usually, ang gigamit during programming is this one, the approximate percent relative error. So, gingon na natin para aware sad mo. Okay? Okay. So, ang atong stopping criterion is 0.5 niya. 3.43 pa man padayon sa dan So, get f of xr3 xr3 f of 14.5. Ang value ana niya is ako na lang isulat. F of 14.5. Ay. XR. Solvon pa din calculate pa din Okay, so the value of f of 14.5 is 0.5523. So we'll check f of 14 times f of 14.5. Pila ang 14? F of 14 is 1.569 times 0.5523. So greater than 0. Okay, so since greater than 0, you set XL equal to XR3. Okay? Okay. So you have now XR4 is XR3 is 14. Your new new interval is XL is 14.5 and XU is 15. So you have 13.5 plus 15 over 2. Pila answer ani? $14.75. Oh, ang true value is 14.78. Dul na. So the approximate error is 14.75 minus the old value 14.5 over 14.75. So pila ni siya. $1.69. 1.695, 1.695%. So dol-dol na good. And mapansin ninyo is ang error is half, right? Ang next nga error from 3 na himong 1.6. No, so gihap na pod. So you can expect nga next error ihap ra gyapon. Okay? So 14.75. So f of 14.75 is pila value. Kalkiwa na pod. 1 minus okay, the value is 0.059. Okay? 0.059, and then multiply f of 14.5, f of 14.75. So 14.5, ilagay itong value ko kanina. Okay, so f of 14.5 multiplied by f of 14.75, the answer is positive. So therefore, set x r equal to x u. Ano? Set xl equal to xr. Okay? Nasa upper interval ang imuang roots. Okay? Upper interval. So therefore, your new interval will be 14.75 and xu is 15. Okay? And then proceed. xr pila man ni xr5 is 14.75 plus 15 over 2. Ilang na? 14.875. 14.875. So check na to pila error ani. Ang error ani is kamo na lang solve, no? Dali na. Error is 0.84%. So dul-dul na gid. Dul-dul na sa 0.5. So makita ninyo from 1.6 ang 1.695 divide to 0.84. So katunga. So kung ikatungaw na to ni makuha na to ang final value. So buhaton na ni, check na po nimo, kuha na po nimo ang f of 14.875. Pila na siya? 1 minus. Okay, so the value of f of 14.875 is negative 0.1841. Multiply na to na sa f of 14.75. The answer is positive times negative point. So the answer is less than 0. So set set xr equal to xu. So our new interval will be 14.75 and xu is 14.875. Therefore, our new xr6 is 14.75 plus 14.875 divide 2. So ang answer na is 14.8125. Okay? So i-check na tong error na. Ang error na is 0.422%. So less than 0.5%. Okay? So the final value kung atong tan-awon, ito na siyang i-summarize. Atong i-summarize, iteration XL, XU, XR, and the error. So nakapila ta XR6, so you have 6 iterations. 12, 14, 14.5, 14.75, 16, 15, and then 14.875. The roots 14, 15, 14.5, 14.75, 875, 14.8125. Okay, the error is 1695, 84.422. Okay, so the final answer is this value. Okay, less than satisfies the stopping criterion. Okay, so that's it. You can make a program for this para dili na laborious ang pag-solve. So that is why you have numerical methods, so that you can automate the finding the value of the roots of equation. Okay, so kung imoning siyang gaman o program, it will be much easier for you.